simulation for part 1 of the assignment. First, we must make sure the gain values are at initial. Then check the value for the transfer function. Click OK. Then change the stop time to be 10 seconds. Then click Run to begin simulating the outputs. When it is done, click onto the scope to see the current, torque and speed graphs. The graphs for speed, torque and currents are as shown. That is it for part 1. This is the simulation for part 2. For present circuit, we need to make sure the gain values are at initial. Then click onto the transfer function and change it into these values. Then click Apply and OK to proceed. Make sure to change the stop time to be 2 seconds. Then click Run. Click onto the scope once it's downloading the simulation. The speed, torque and current graphs are shown respectively. The redesigned circuit are now being simulated. The gain values are changed based on the calculated gain values. Once done, click Apply and then OK. Make sure to check the stop time and then click Run. Once it is done loading, click onto the scope to obtain the output graphs. That is the end for part 2.
This is part 3 of the assignment. First, we have to make sure that all the gain are at initial value as in part 1. As for the reference speed, we add a constant of 1000 RPM. Then, we add a step function with final value of 5. This value indicates the load of 5 Nm. Then, we will run the simulation and we will see the graph of speed, torque and current. This is the graph of speed, torque and current. To improve the speed and torque control performance of the motor, we change the value of gains and inertia. So, this is the new value of gains and inertia that we obtain from the calculation. Then, we will run this simulation. So, this is the graph that we obtain. As we can see here, for speed, the response times for the motor to maintain its speed is so quick compared to the previous one. As for part 4, we have to observe the maximum load that can be handled by the motor while maintaining its speed. So, we set the load to be 21 Nm and then we will run the simulation. This is the waveform that we obtain. As we can see here, the torque still able to maintain with the speed at 1000 RPM. When we set the load to be 22 Nm and run the simulation, we will get this result. As we can see here, the torque is a bit higher from the previous one. So we can conclude that the maximum load that can be handled by the motor while maintaining its speed at 1000 rpm is 21 Nm. Then, to increase the torque capability of the motor, we increase the value of friction to be 0.01. Then we will run the simulation, and this is the waveform that we obtained. As we can see here, the waveform does not exceed 20 Nm.